Imagine taking the entire mass of our sun, all its turbulent plasma and overwhelming gravity, and crushing it down into a sphere that could fit inside the city limits of a single metropolis. Based on the behavior of matter on Earth, squeezing that much material into a space 20 kilometers wide sounds like a physical impossibility. These objects exist in the deep reaches of space. They are neutron stars, and they stand as some of the strangest and most extreme phenomena in the known universe. This presents a puzzle. How can an object so small become one of the densest things ever discovered without shattering the established laws of physics? Understanding this star requires us to move past the normal rules of matter and see what happens when gravity pushes physical reality to its absolute limit. A neutron star begins its life when a star much larger than our sun exhausts its nuclear fuel. Its core collapses inward, triggering a supernova explosion. If the surviving core avoids becoming a black hole, gravity becomes so intense that it forces negatively charged electrons to smash into positively charged protons, merging them into a solid sphere of neutral particles, neutrons. This material is heavy on a scale that is difficult to process. A single teaspoon of this neutron matter would weigh roughly 1 billion tons here on Earth. This spectrum maps cosmic density. On the far left, we have Earth and our sun. Further right are white dwarfs. And finally, the black hole. The neutron star occupies the final point just before total collapse. These objects represent the final physical boundary of how tightly matter can be packed before reality gives way to a black hole. The massive collapse forces the star to spin hundreds of times every second. These rapidly rotating stars often emit powerful beams of radiation from their poles, earning them the name pulsars. From our perspective on Earth, these beams look like a cosmic lighthouse sweeping across space. Some neutron stars evolve into an even more extreme variant called a magnetar. A magnetar possesses a magnetic field trillions of times stronger than Earth's. These stars occasionally fracture under the stress of their own magnetic power, erupting with powerful bursts of radiation. These unbelievable levels of rotation and magnetism turn dead stellar cores into the most energetic engines in the universe. Scientists study these objects using radio telescopes, X-ray observatories, and gravitational wave detectors. When two neutron stars collide, the event is powerful enough to send ripples through the fabric of spacetime. These violent cosmic collisions forge the universe's heaviest elements, including the gold and platinum found on Earth. Despite these observations, we still do not know what exists at the very center of a neutron star's core. While established research tracks the outer layers, scientists continue to debate whether matter breaks down into exotic new forms under such crushing pressure. This illustrates how these stars can exist under such extreme conditions. Neutron stars reveal how extraordinary the laws of physics become when gravity reaches its absolute limit. They remind us that the universe still holds many objects that appear impossible simply because we have yet to explore them. To keep exploring the greatest mysteries of the cosmos, subscribe for more documentaries on space and astrophysics. Thanks for watching.